Module 7 Mechanical. Hi, Joe Cerrone, CAD 116 Basic AutoCAD. Today we're going to take a look at this mechanical drawing, and we're going to apply these dimensions to the drawing. And so as we take a look at it, we can get the instructions for the module mechanical drawing right here. And the project exercise gives you step-by-step instructions for creating the dimensions for this mechanical part. And so as we look at the mechanical part, we'll start AutoCAD. We'll use a dimension layer and we'll make that layer blue and continuous. And then we'll go through and we'll create the dimensions for this mechanical design right here. And so let's get started. In D2L, we have the geometry for the mechanical part right here. And so you can download it and you can open it. And that's my properties panel. I'm going to open that up a little bit. And so this is our mechanical part. We have our object lines on the object line layer, and then you can clear those grips by hitting the escape key, and then if we click on one of the red lines, that's on the center line layer. So we are separating the line types by different layers so that as we go into the manufacturing process, we can turn off and generate tool paths or other analysis for the mechanical parts. If we take a look at the drawing, we're going to put this linear dimension here, which is 4 inches. So we're going to go ahead and get that started. So as we look at our drawing here, we're going to be on the dimension layer, and then we're going to get a linear dimension, and you can get that in the Home tab or you can get that in the Annotate tab. You can also get dimensions from the dimension pull downs if you have the dimension toolbar enabled. And to enable that toolbar, you would enable it here. So it's either on or off. And so if I hide it, disappears. And if I show the menu bar, it reappears. Dimensioning is quite robust in AutoCAD. It can dimension just about everything. But it's a fairly simple process. When we dimension something, we want to be able to communicate things like the distance between this center point and this center point. So we would dimension to the endpoints of the center line and then place that dimension. Continuing. And so as we look at these different types of dimensions, we can put in aligned, angular, arc length, radius, diameter, and you can get those and see those just like they are in the book if you hit these little triangles and get the pull downs. And so it's a very visual software. As we continue, we're going to put these dimensions in here using the aligned dimensioning command. And when we put them in aligned, it would be parallel. And so we can go to the aligned, and then you want to use your O snaps. And so as we're working with our drawing, we want to have our object snaps enabled. And so these are our drafting settings. Now we don't need the grid and the snap on, so there's our disabled. Polar tracking I always like to have on, so we'll leave that enabled. And then object snap. Okay, this means that when I'm near an endpoint, I'll get a little green square that'll light up. When I'm near a midpoint, I'll get a little green triangle that'll light up. And so object snaps come on when you're in a draw command, or when you're in a modify, or when you're in a dimension command. Alrighty. So we're going to put in an aligned dimension here. We'll get the endpoint here, and then the endpoint here. Make sure that you get the endpoint, or that it looks like it's the intersection. Those look like the same, so I think we'll be fine. And the dimension is reading correctly, and so we'll just place that there. Notice that the decimal accuracy is the same, 2 decimal places. If we click on the dimension and right click, you can increase the dimensional accuracy. And so if we went into the precision, we could bump that up 3 decimal places. So for example, if this is a critical fit for some manufacturing process, by having more decimal accuracy, it becomes a better design or more accurate. I'm going to put it back Alrighty. We'll add another dimension, and this dimension is a little bit tricky to put in because it's an aligned dimension, and in order to be an aligned dimension it has to be offset 3 inches from here and then extended to the center. And you might say, Joe, how come it's like that? And it's just the way AutoCAD kind of works, you know, in some of these basic drafting techniques. And so what you want to do is you want to go to the Home tab, go to the Offset, and you can offset either through or through a point. And so I could just select a point to offset, or I can offset at a distance. I'm going to offset at a distance of 3 inches. And so what I'm going to do is specify the offset, and I'm going to say D for distance, and then I'm going to say 3. Enter. Select this line, offset it to that side, and escape. And then I'm going to extend this. Good drafting technique is to have that pointing to the center just a little bit closer. If you ever had anybody teach you how to draft with a pencil, these are the way of communicating the center, the distance between centers between this slot and this center of this circular feature. And the reason this is failing right here is because I did not use the align dimension. So I'm going to erase that, and then I'm going to grab the align dimension. And there we go. All right, continuing. We have this geometry all constructed here. Everything looks fine here. We're going to add a dimension between these 2 points using the align dimension again. And this one looks like these are not even, so we're going to need to even those up. And what I'm going to do is I'm going to draw a line, and I think I'm just going to offset this line and then draw a line between it. And so what I can do is I can draw a line from here, and I'm changing my mind as I say this, and make it perpendicular to this line. And then I'm going to trim this other line so that the endpoints are even, and I can put an align dimension in. And there we go. We're going to put in a dimension that's aligned for the width across flats of this polygon shape. Align dimension, and then when we select the dimension, we want to select it at this point here and at this point here, and then bring that out. The next step is to put these angular dimensions on the drawing, and so we have this 22.5 degree angle and this 45 degree angle. And so we can come back here into our CAD drawing, and we can select the angular dimension tool, and then we can select this red line here and this red center line here, and then we can just bring that out. I like to try to line up the dimensions so your eye kind of follows and begins to learn how to read the parts and what's important within the drawing. And so here we have 45 degrees. Now this one says 45.0. We can dial down that precision if we want to be exact. And then we can put in the other dimension of 22.5, which we should just have to put in without a change in the precision of the units. And so that line is going to be between this line here and between the red center line. And that's going to give us 22.5 degrees for the angle that the hex polygon is located at. Next, we're going to add some radial dimensions. And so radial dimensions are dimensions that give you the radius of this arc here, this arc here, this arc here for the slot, this arc here, this arc here. Notice that holes are dimensioned with diameters, not with radiuses, because we don't want to have to do the calculation. We just want to get a drill that's 1 inch in diameter. And here's another radial measurement that we're going to add. All right, when I put radius dimensions on, or when I do any type of dimensioning on a drawing, I'll just kind of work my way around the part. And so we'll just go counterclockwise around here and add those dimensions. And so we'll find the radius, and then we'll go and select the arc, and then we'll place that. And as we place that, what I'm going to do is I'm going to disable the center mark. And so I'm going to go into properties, and this is just one of those things that I find is better not to have a center mark on top of a center mark. And so I clicked on it with a grip, and then I opened the properties, and what you can do is you can disable the center mark and say none, and we can hit escape, and that will then avoid having double center marks. Now, last chapter that we read in the textbook on the dimension styles, which is located in the annotate tab right here, you can disable the standard dimension center mark maker by saying modify, and then what you want to do is go to symbols and arrows and select center marks, none, and then you don't have to go through and remove the center mark because you have a double center mark. And the way that I was taught was to create center lines on a center line layer, not to automatically have them annotated within the dimension style. So it's kind of a thing that the computer programmers thought, hey, this is great, it's efficient, but from a standards point of view, I prefer to stay with the standard of just keeping them on different layers. All right, radius of 6 inches, let's go and put that on there. When possible, you want to avoid crossing dimension lines like this. And so I was kind of looking to see where I could place this. I might be able to kind of scoot it in here, and then I'm going to hit escape. If not, you can always click on this grip and pull this one back, and then you might want to pull this one back too. You don't have to, and that's kind of how you keep the drawing looking neat. You want to avoid crowding dimensions, and so it should have somewhat of a starburst effect, as you like lines radiating from the sun, like a sun icon. Radius 1/2 inch, radial dimension, select the arc, and I selected the wrong one here, so let me put that one off. All right, continuing, radius 1.25. And then we're going to put this radius of 1 inch. I'm just going to right click, and that's sort of how AutoCAD works. It likes to go left to right on the mouse clicks. It gets to be really quite quick. And then we have our last dimension, which is this 3-inch diameter. And I guess I have 2 more dimensions. I've got this 1-inch diameter as well. And that's very common for CAD people, is to pull dimensions for the guys in the shop. And so oftentimes as an engineer, you'll open up a drawing and a machinist will ask you for a location dimension for something like a hole. And so the CAD person will go up and analyze that and add that information to the drawing. Diameter. Alrighty, so the drawing's well annotated. Let's see if we have anything else here. This would be bonus, and so that would be another exercise. So that completes how to dimension this, and what I prefer people do is to add a title block. We'll accept this without a title block, but to add a title block, the way it's set up, we've just got these layout tabs by default, the way that this program was set up. If we right click on one of the tabs and say from template, we can download a template from our D2L system. So I can come back here to D2L, and then I can go into my templates, all title blocks, and I can download a V-size mechanical, and it's a DWT file, which makes it a template. It acts the same way as a drawing file. Now it's downloaded it, and I just keep it in my downloads. And so what I'll do is, rather than open the drawing, I'll just insert it from my downloads. And so what I'll do is I'll come back here to my CAD drawing, and then I'll right click on layout and I'll say from template. I'll navigate to my downloads, and here's my B-size mechanical. I'll open that. You can add comments to it. These have comments. It just tells you it's a B-size mechanical. We'll say OK, and there it is. And so here's our B-size mechanical title block. We can double click in the viewport. We can put that in the viewport. It's larger than full scale. It won't fit. If we check the size at 1:1, it fits, but the dimensions don't fit. And so if we're going to make this a scaled dimension, I would put it at 1/2, place it on the drawing, and then I would lock the viewport. And that way it's scalable. And then here's our title, and this will be our MEC Module 7. And it's important that you put on, your information for that, so that they know it's the most accurate drawing. So be sure to complete the student name, and then we'll save that drawing and turn that into the D2L system. Alrighty then, this completes Module 7 Mechanical.